Hi, so I've been doing some codes here, I've been doing some work, but in the past few months I have not doing many videos. I was just doing other type of works from the university, and I wanted to take again some of the problems that are shown in this site, which is Cody. Basically, Cody is a page, is a site that has a lot of problems where you can develop your skills for MATLAB algorithm writing or algorithm creations. So let's try some problems. I took one from the coding challenge, and it's the problem 29, the nearest numbers. So let's try this. So what does the problem says? Giving a raw vector of numbers, find the indices of the two nearest numbers. Okay, so you got examples. So you get you need two answers, index 1 and index 2, and you need to make a command called nearest numbers and an input of a vector. Okay, that's quite interesting. Let's see this uh, from another perspective. Okay, so we have a vector of numbers. So a vector is a group of numbers. You have to find some way to work with them. Maybe organize them, or maybe like make some function to all of the components of this vector. In this case, we are asked to find the pair that are the nearest numbers. So that means, for example, we take 2. So let's choose another color. 2 and 5. So the distance between those numbers is 3. And maybe 2 and 3, and the distance between these two numbers is 1. And then 2 and 10, and the distance between these numbers is 8. And you can do this for all the components of the vector and find which one are the nearest, talking about distances. We are supposing, I guess, that there is only one pair of numbers that is the nearest one, so nothing like 1, 2, 3, 4, and all the numbers are of equivalent distance. And after we find, in this case, this pair that is 2 and 3, we have to give the indices. So since 2 is the lowest number, we should return the index, which is 1, and 3 is the greater number or the bigger value. Then you have to return the index 3. This is the 1 indices, 2, 3, 4, etc. So that's what's given on these nodes. So the indices should be returned in order such that the index 2 is bigger than the index 1, and there will always be a unique solution. Okay, so there is only one pair of nearest numbers. Here is another example, and we can try with every pair. In this case, it says that the nearest numbers are between 2 and 4, so 14 and 17. And the answers are 2 and 4 because that's the indices number of these components. So let's try to make this. Okay, so now I'm showing how to make this code. It takes too much time. I think this is kind of a difficult problem, and also because I haven't taken uh, this type of problems on in the last few months. So yeah, I'm gonna explain it, and yeah, I prefer to make it on MATLAB because it's more easier to work with. So remember, this type problem show like this. We have a vector, we have a lot of elements of the vector, and we have to find which one have the smallest distance between them. So in this case it's 2 and 3, but we don't know about that. It could be maybe this one and this one, could be this one and this one. So how we can make sure that this pair is the correct one? Uh, as far as I know, you have to make a triangle error. method with all the elements. So what do I mean with that is we have to try to get all the pairs, like 2 and 5, 2 and 3, 2 and 10, 2 and 0, 2 and minus 3.1, and then 5 and 3, 5 and 10, 5 and 0, etc. until you end with the last pair, which is 0 minus 3.1 in this case. And yeah, so first we made the code like getting the length, because it's easier to work with the length of the vector. It could be any vector with 3, 5, 100 elements. And yeah, so L is a good way to get the size of this vector, the number of elements that we are going to work with. Then we call another variable, which is going to be the minimum distance. In this case, we're gonna call it like min, which is the absolute value between the difference of the first and the second element. Uh, for sure, we don't know if this first pair is gonna be like the correct one, but we have to start with something. So just for the sake of calling something min, we get the first and second element. Also, it's an absolute value because in this case, if we start with 5, let me check. Okay, in this case, that could happen. So what we are doing is making a subtraction of 2 and 5, and we get minus 3. We need the value as a positive number, so we need to get the absolute value, which in this case is the distance between the numbers, and it's 3. So that's why we get the absolute value. And then we are calling do, well, that's the way I have made this code. We are calling use value 1 and value 2, just two random variables to get like to identify the elements, sorry, to identify the elements of a pair that has the minimum distance. Mhm. So also I have make an assumption that value 2 is bigger, is the bigger number, is the bigger number. So that's why when this value is the bigger, this value 2. And another case, when this value is bigger, then this value 2. So this is, we just do this to start. Then we have to make the iterative part of the code, which is checking for all the pairs. This. So we just make for I equals 1 through the length minus 1. Okay. And then for a j of 1, sorry, I plus 1 to L. So we start from here and to here. Mhm. Here to here, and then the other one is gonna start here to here. So in this way we don't check the number with themselves. So I know resting 2 minus 2, 5 minus 5, etc. And yeah, in this way we can check for all the pairs. There is no problem with that. In the case we have a pair that has a smaller distance, we just recall min as the difference of this new pair. So if this happens, which is two numbers that are nearest than the previous pair, min is gonna be that difference on absolute value. So for example, if we start with 2 and 5, the distance is 3. But then 2 and 3 is a difference of 1, and this is the new pair. This is gonna be the new pair. Min is gonna be 1 instead of 3. And yeah, um, then we make a case by case. In the case the first element is the bigger one, the second element is the bigger one, or if both numbers are the same, that could also happen. Like we have a vector with, I don't know, 2, 5, 8, and 2. So the nearest number is gonna be 2 and 2. Yeah, that could happen, so I put that condition. And we do the same that we did at the start. Value 2 is gonna be the biggest number. And that's the iterative part. This part is just checking all the pairs. And yeah, the final part of the code is gonna be like we need the answer as indices, not as the elements. So we just check which index is for value 1 and which index is for value 2, and that's it. So when we get the value 1, index 1 is going to be that index, because we're making for a k equals 1 through length, and we're going to check just for all these numbers. Sorry. So in this case the numbers are value 1, let me check, value 1 is going to be 2, and value 2 is gonna be 3, because those are the numbers that have the less distance between them. So in this iterative part we just check which one is 2. So from all these numbers, which one is 2, and that's gonna be the index. So in this case it's 1. That's index 1, and then we check which one is 3. From all these numbers, which one is 3, and that should be this one, and the index is 3. So index 1 is gonna be 1, index 2 is gonna be 3. So that's what this means. And yeah, just for the last case, that we have a vector with two elements of the same value, like as I said in the past. Let me check. There is a case here that show that. I'm not sure which one it is. It's not that one. Oh, it's this one. Okay. Mhm. So in this case, we have 0 and 0, and yeah, in the case that happens, this is gonna be like our value 1, and this is gonna be our value 2. We need to make another call for this, because this one doesn't work. If we make this, then it's gonna say that the indexes are gonna be 5 and 5. So yeah, a bit of thinking here. It took me a while. Yeah, literally it took me a while to take this. So I create a counter, and then after a while I create a for 1 through the length. Um, on that situation, I just try to get the first indices that happen. Since I already made this code, uh, both index 1 and index 2 is gonna be the biggest index, and I just need to look out for the first index that has been erased. That's gonna be the smallest index, and it's gonna be index 1. And when that happens, I update the value of counter into counter plus 1 and make a break. When I make the break, I get out of this uh, iterative process, and since it's not more counter is not more 0, it's not gonna happen anymore. So it's just a one-time thing, like a one night stand. And yeah, that's the way I make this for the case that both value 1 and value 2 are the same. At last, I just make uh, uh, a mini algorithm in which I'm not making sure that value 1 and value 2 are on the correct order. It could happen that, uh, how to say it, my index 2, sorry, my index 1 is going to be 3 and my index 2 is going to be 1. That's a problem, so I just order those values. So if this is the case that index 1 is the bigger one, I just reorder the values. I create another value which index 3 just to take index 1, and then index 1 is going to be the smallest one, and index 2 is going to be the biggest one. So yeah, I'm just trading the values of index 1 and index 2, and that's the end. So this is the code, and it worked for all these tests. I'm happy with this. I think this is a better way to make this, because trying to write the code live, it's good, but it takes too much time. And yeah, I think explaining the code is better because it helps the understanding. And yeah, that's it. Thank you.